Welcome back. In the last topic, we discussed Amazon S3 data lakes and object-level storage. In this topic, we're going to discuss structured data storage. Structured data storage is performed through databases. We're going to focus on one specific type of database, a data warehouse, which is one of the most common analytical database solutions.
Data warehouses are used as a central system for storing analytical data from multiple sources. Say a company has lots of different databases because different departments use them to track different things. And that's fine, but that makes it difficult to get a good idea of what's happening across all the departments at once. A data warehouse is a central repository of structured data from many data sources. This data is transformed, aggregated, and prepared before it's loaded into the data warehouse. The data within the data warehouse is then used for business reporting and analysis.
Data warehouses are databases that store transactional data in a format that accommodates these large, complex queries. Warehouses have been the backbone of business intelligence for decades. From small businesses with a relatively small data set to enormous businesses with exabytes of data, you can use data warehousing to make sense of all kinds of data.
On-premises data warehouses take a significant investment to plan for, configure, and maintain. For many smaller businesses, that's just not an option. However, AWS provides a data warehousing service called Amazon Redshift. Amazon Redshift lets you set up and deploy a new data warehouse in minutes. It's built to store and query data sets ranging from gigabytes to petabytes in size. So, now what we've got is Amazon S3 that can host a data lake and Amazon Redshift that can host a data warehouse. But what if I need to query across both spaces?
I think I have a solution for that. It's called Amazon Redshift Spectrum. Amazon Redshift Spectrum allows you to combine your data lake and your data warehouse as if it were a single source of data. No data movement, no crazy query logic, just clean queries of all your data. So now it's possible to execute a single query against exabytes of data.
Okay. Wow. Change of concept.
Okay.
Let's discuss a few pros and cons about hosting a data warehouse on premises versus hosting it in the cloud. Now, the biggest benefit of data warehousing, regardless of location, is fast, centralized data retrieval. Data warehouses provide curated data sets that can be used for a variety of analysis and reporting needs. And this allows you to drive timely business insights that can help you make better decisions more quickly.
Now, traditional on-premise data warehouses do have some downsides that can be significant, namely their cost. Small businesses may not have the time or resources to purchase the hardware and software required to configure the rules and constraints to keep the data consistent and perform the extract, transform, and load operations. And then there's the ongoing maintenance and security concerns. Finally, there's scalability. Traditional data warehouses usually can't scale to meet the unpredictable demands of those business workloads.
So using Amazon Redshift, a cloud-based data warehouse solution, can help you address all of those concerns. It's cloud native, and it provides up to 10 times the performance that can be achieved with a comparable on-prem data warehouse solution. Now, I've mentioned analytics a few times, and I want to make sure that we cover the connection between data and storage thoroughly. In a traditional on-prem data analysis solution, ETL operations gather data. These operations transform the data into the required format and place it into the data warehouse on a schedule. You would then run any required analysis against this relational data warehouse. These analysis processes are limited to the data within the data warehouse. In today's data landscape, this is a huge limitation, especially considering the breadth of data that's available to businesses.
No doubt. Business applications commonly store data in the form of CSV, XML, and JSON files. Data lakes combined with Amazon Redshift data warehouses are an elegant way to complement the data stored in the data warehouse. You can create a data analysis solution that spans structured data in the data warehouse and the semi-structured data stored in the data lake. All data becomes visible and available for all of your reports and dashboards.
Another key advantage of the AWS ecosystem is the ability to use everything in the data lake for machine learning and real-time analytics to accurately predict future outcomes. So, let's recap this a bit before we move on.
Yeah.
We've discussed several recommendations for storing data. At the object level, we recommend Amazon S3. When storing massive volumes of data, both structured and unstructured, we recommend building a data lake on AWS.
When storing massive amounts of structured data for complex analysis, we recommend storing your data in a data warehouse using Amazon Redshift. And we have one more recommendation.
And this is for the ETL process that generates analytical data sets. Within the AWS ecosystem, there is a tool for creating ETL operations called Amazon EMR. Amazon EMR is a managed Hadoop framework. Remember we talked earlier about the challenge of ingesting huge volumes of data quickly and rapidly producing insights? Well, this is what Amazon EMR does. Hadoop is an open source framework. It's been around for a long time and is well established in the data processing world.
So hang on a second here, Blaine. Before we continue talking about what Hadoop is, let's take a second and define what Hadoop is not. Sometimes it's a little more helpful. Hadoop is not a database. It is not a replacement for existing data systems. It is not a single application. Instead, it's a framework of tools that help you to both store and process data. Now, that storage is temporary while you're processing that data. For now, let's go ahead and focus on just this temporary storage part of the framework.
Hadoop supports rapid data transfers, which means you can speed up the processing time for complex queries. Whether you use Hadoop on premises or Amazon EMR, you will use the same tools with one major exception. Amazon EMR uses its own file system, and that means you can use your Amazon S3 data lake as the data store. So there's no need to copy data into the cluster as you would have to do with Hadoop on premises.
You know, in fact, Amazon EMR's file system can catalog data within Amazon S3 data lake from an on-premises Hadoop file system at the same time. It combines the greatest benefits of our data lake, combining data warehouse data and data lake data. Now we can even combine Hadoop data into this large single storage location for our data. It gives us the best of both EMR and Hadoop processing systems at once.
Storage is the foundation for any data analysis solution. It's vital to understand your options so you can decide which storage method is best for your data analysis solution.
Now in this lesson, we covered object-level storage and the benefits of creating a data lake to bring data from many sources and in many forms together into a single location. We discussed the advantages and disadvantages of structured analytic storage using data warehouses, and we covered the importance of carefully considering how to create ETL operations. In the next lesson, we will discuss high-velocity data analysis solutions.